Assalamualaikum warahmatullahi wabarakatuh. So today we are going to present about application of differentiation, which is related rates. So this is my teammates, which consists of 3 persons, which is me, Rabiatul Farah binti Rosli, Nur Adibah Nadra binti Nur Rupani, and Marisa binti Muhammad Faisal. Differentiation consists of 5 applications, which is related rates, analysis of functions 1, analysis of functions 2, apply max and min problems, and also rules theorem and mean value theorem. So today we are going to discuss about related rates. What is differentiation? Differentiation is a method used to compute the rate of change of a function fx, and is known as the derivative of f with respect to x. The first derivative of a function y equal to fx is denoted as dy over dx, where dy is denotes as infinitesimally small change in y, while dx is an infinitesimally small change in x, and it is defined by dy over dx equal to limit as h approach to 0 fx plus h minus fx multiplied by h. So what is related rates? Related rates is one of the application of differentiation in the fundamental theorem of calculus is related rates. Related rates are rates of change associated with 2 or more related quantities that are changing over time. These are involved in determining the rate of change of a quantity based on the information about another related quantity. The related rate technique is often used in real-life application. For example, a spherical ball is being filled with air. Both radius and volume of the ball are increasing. Arguably, the rate of change in the volume V is related to the rate of change in the radius R. In this case, dV over dt and dr over dt are related rates because V is related to R. There are some steps in solving related rates problem, which is 1. Read the problem carefully. 2. Draw a suitable diagram if possible. 3. Identify the rate of change that are known and the rate of change that is to be found. 4. Use chain rule or implicit to differentiate both sides of equation. And lastly, write an equation that related the various quantities of the problem.
The first problem statement is a 13-meter ladder is resting against a wall as shown. If the top of the ladder is being pushed down towards the floor at the rate of 1/4 meter per second, how fast is the angle between the bottom of the ladder and the floor changing d theta over dt when the angle theta is pi over 6 radian? So as the previous video said, the first step is we should bring out the keywords in the question. So I already bring out them, which is dw over dt equals to negative 1/4 ms, which is we could see it here. The top of the ladder is being pushed down towards the floor at the rate of 1/4 meter per second. Why is it negative? Because it is being pushed down. So the second information is d theta over dt. We are finding the d theta over dt when theta is equals to pi over 6 radian. If the 3 informations is already here, then we are ready to the next step. So the first one is we should find the w because we want to find the angle at the top here, because we already have the angle at the floor, so we should find the angle here, which is sin theta equals to O over h equals to w over 13. So w equals to 13 sin theta. After that, we will differentiate the w to get the dw over d theta equals to 13 cos theta. Moving on to the second step, we should find the d theta over dt equals to d theta over dw times dw over dt. We separated the d theta and the dt. So here we have dw over d theta, right? And here is d theta over dw. So we should change the position, which is 1 over 13 cos theta. And then we times it with negative 0.25. And then we will get the first equation, negative 0.25 over 13 cos theta. Moving on to the last step, which is we want to find the value of d theta over dt. So when theta is equals to pi over 6 radian, we will substitute it into the equation. Negative 0.25 over 13 cos pi over 6. And the final answer is negative 0.0222 radian per second. This is the final answer. Here is the second problem statement, which is milk is poured into a conical container at the rate of 8 meter cube per second. The radius of the tank is 3 meter and the height is 9 meter. At what level is the milk reach 3 meter deep? Okay, first of all, we need to find the keywords. We can find out the dV over dt equals to 8 meter cube per second. Add here in the equation. And then we need to find the level, which is the height, dH over dt. We need to find this. And then I separate these two, dH over dt equals to dH over dV times dV over dt. Okay, here is the volume of conical. This is the formula, which is volume equals to 1 over 3 pi r square h. And then we need to find the radius. So I take the radius per height equals to 3 over 9. And then you bring 9 at the left side. You can get 9r equals to 3h. And you get the radius, which is radius equals to 1 over 3h. And then you substitute here in the formula, which is 1 over 3 pi times with 1 over 3h square height. So you get a 1 over 3 pi times the 1 over 9h cube. And then after that, you times these two value and then you get a 1 over 27 pi h cube. And then you need to differentiate. And then you get a dV over dH equals to 1 over 9 pi h squared. And then you change the position, which is dH over dV equals to 9 over pi h squared. Moving on to the next step, which is we can substitute the value in this equation, which is dH over dt equals to 9 over pi h squared times with 8 meter cube per second. And then you can get a 72 over pi h squared. And then when h equals to 3, we can take this from the equations here. And then you substitute h into this, which is a dH over dt equals to 72 pi 3 squared. And then you get the final answer, which is 8 over pi meter per second. Thank you.
So for a summary for today is differentiation is a method to compute the rate of change of a function f(x), while related rates is the rate of change of associated with two or more related quantities that are changing over time and used often in real life. There are some of related rates application in real life, which is observing the horizontal and vertical motion of space shuttles and their tracking cameras, estimating the distance and speed of a docking board from the shore, and calculating the rate of change of an object's kinetic energy or effective resistance.
That's all from us. Thank you for watching. Don't forget to like,
Comment.
and subscribe.
Bye.